All right, hey guys, thanks for coming out nice and early. Yeah, so I guess I thought I might just start off by running through our pitch deck, because that'd be a nice succinct way of telling you what we do. And from there, I'll try and talk a bit about our journey getting to where we are today, and I'll keep it pretty open, so if anyone has any questions, pipe up. This is our pitch deck, and I'll quickly run through it. So we're rapid phenotyping, and our mission is to build mobile devices that put the power of a lab in the palm of your hands. And now most people, when they think of lab testing, they might think of medical testing, blood testing, things like that. We're definitely working on that sort of stuff, and this platform is very broad in its application. However, our focus is on agricultural testing, and you'd be surprised how much testing does occur in agriculture. Farmers test their soil before they sow, they test their crops as they grow, and they test their produce to maximise the returns from their harvest. That produce or those commodities are then tested throughout the supply chain every time it changes hands. Now, currently, if a farmer wants to conduct a soil test or a crop test, they need to go out in the field, collect that sample, bag it up, label it, take it back to the farmhouse, get on a website, register it, print out a sample submission form, drive it into a post office that's often hours away, and that sample then gets delivered to a lab, which is often on the other side of the country. And that lab will have skilled technicians using expensive machinery to generate results that get sent to the farmer maybe 1 to 3 weeks later. And that's often not enough time for them to make a decision on what they want to do. So this process is slow, inconvenient, and expensive. So our solution is the Smart Lab. It's a multispectral device that generates a complex molecular fingerprint of anything that's placed inside it. And so this molecular fingerprint contains over 22,000 data points. And essentially what we've done is reduce 3 scientific benchtop devices down into one handheld device. Now, this complex fingerprint is then decoded by our software, our machine learning software, that churns in the background and spits out a result. And that result needs to be developed or calibrated before you can conduct a test on our platform. So using this technology, the farmers will now be able to conduct tests on site on the farm to maximize their yields. And throughout the supply chain, testing can now occur in real time. And the end users of the products, the bakers, the brewers and the feedlots, can now test the quality of the commodities that they buy. So obviously the agricultural market is huge in Australia, 167 billion. We estimate approximately 3% of that is for testing and compliance. And globally that's a smaller percentage, because a lot of third world countries just don't have the capability to do this sort of testing. And when we get out there and talk to people, what we hear over and over again is that more people will be testing more of the time if it wasn't so slow, inconvenient, and expensive. So our business model, as I said before, our device and software kind of work together as a platform. And we like to think of it as something like the App Store. So, you know, Apple built an iPhone and an App Store, and then developers can develop apps that they can list on the App Store, and then users can download and pay for those apps and use them. Using our platform, we work with development partners on the supply side of the marketplace to develop new calibrations or new tests that can get listed on our platform. And then on the demand side, the farmer or the agronomist can then use those tests, and we share the revenue from that with the development partner. And so we work with development partners. They sign up to our development program, they purchase the devices from us, and we work together to develop the calibrations with them. On the farmer or the agronomist side, they pay a monthly subscription. We give them a device and they get a certain number of tests that they can conduct per month. There's a number of competitors in this space. They generally fall in two categories. One is scientific instrument manufacturers, so people who build high-end, expensive, large benchtop devices. And there's a few other startups in a similar sort of category to us. There's one called CSIRO who build a small, cheap consumer device. We believe ours differentiates massively from this. They're aiming at a consumer market with very little capability within the device. Our device is aimed at a business-to-business market and has a lot more capability to test for a lot more things a lot more accurately. And to put that into perspective, the CSIRO device produces approximately 20 usable data points. Our device produces over 22,000. So we're capable of measuring a lot more things with that information. We've lodged a number of patent applications, and we put a lot of development work into the machine learning back end that just gets better and better over time. And we're currently changing the way farmers test their grain, which is the first application of the technology. And we've got a number of development programs going in rice, cotton, cannabis, soil, and a number of other things. Hey, how's it going? We believe that with our marketplace approach, we'll be able to scale out into a number of different industries rapidly. So by using the development partner approach, it gives us the capability of scaling out into medical, water monitoring, mining, construction. There's an endless amount of things that we could develop applications for. Yeah, so that's the pitch. Hopefully that gives you a bit of an idea of what we're working on and what we're working towards. So yeah, the name of this event is Startup Stories. So I thought I would just try and run through our journey and how we got to here. It's fairly unstructured, so just jump in with questions at any point. And I'm not exactly sure what I'm going to say. So yeah, so I've got a few slides here. I thought, yeah, I might tell you about the team and how we got together. So the company was founded by myself, William and Jamie here. It was actually registered a number of years ago under the name Red Pineapple when we were going to be a fruit and veg delivery company, something like HelloFresh. Probably a bad decision that we didn't go down that path given the success of HelloFresh. But the company sort of sat there and we were doing our PhDs and we got distracted. And we ended up off at the Hunter Medical Research Institute developing a new 3D imaging technology for imaging medical biopsies. And so we went and did that, and that kind of half paid the bills for a little while, and we're pretty proud of what we developed there. We developed a new type of microscope and and a piece of software called the Virtual Biobank that allows medical samples to be uploaded in 3 dimensions for researchers around the world to examine. So yeah, we got into that, and it gave us some skills in optical development. We built our own microscope, and also dealing with large data sets. These 3D imaging data sets were quite large, something equivalent to what gets captured on the Hubble telescope. So it was a large challenge, and I guess, yeah, that gave us a lot of the skills that we needed to go down the path of developing these handheld optical devices and dealing with these large data sets that our software deals with. We pretty early on realized that we didn't have the coding skills to develop the software that we needed. So we went down to the local coders group meetup at Newcastle University and hustled the coders down there, and we came across Pete here, which is the the best thing that ever happened to the company. Pete's an amazing developer, and he just happened to have the exact skills that we needed. He was an AI developer, and he just brought so much to the table. We could never have got where we are today without Pete. Similarly, we were very lucky to come across Dr. Rod Vance, who's a very experienced optical physicist who's developed products for people like Zeiss and Pentax. And I'm not sure why he wanted to work for us, but he decided to, and it's also one of the best things that's happened to the company. Rod has been sort of very quickly taken over the development of the hardware device, and it's been instrumental in making that happen. He also has a magic bike. Every time he goes for a ride, we get a new patent, which is nice. We have all these very complex problems that we need to solve, and he goes for a little ride on his bike, and he comes back with the answer. And then we brought on Jacob Lorber as a CFO. Where we are a bunch of scientists, we don't really have the business experience, and Jake's really brought some of that to the table. And I guess on that point as well, we made a very distinct decision to go out and find experienced business people very early on. Knowing that we didn't have any business experience, we put together an advisory board, which currently consists of these people, but it's been a changing thing over time, and certainly we would never have gotten where we are today without that advice and the connections from these people that are very much more experienced than us. Yeah, so I guess that's the team, and we've expanded a little bit from there, but these are the core members. Everyone wants to know about fundraising, so I thought I'd run through that process that we went through. In the early days, like I said, we were working at HMRI, and we did have some sort of a wage to support us, but for the most part we were working for free. And I think there's this very early stage where you might have an idea, but you basically have nothing. You have nothing that you could take to anyone who would be willing to give you money. So there's always going to be this early phase where you're working for free and trying to develop just enough to have a concept that you can take to someone that's investable. So so that was the early days, and it was very much a thing that was happening on the side. We got some family loans to give us a little bit of money to do things like register some patents, and even just registering the company and setting the company structure up right, and the government grants, which have been just so helpful for us. We got a very early, small but significant at the time, grant from Jobs for New South Wales. So yeah, that was the very early stages, and we kind of got a website together and a bit of a slide deck, and that kind of gave us enough that we could take it to someone and try and get people excited. So yeah, I think phase 2 was probably bootstrapping, although a number of factors came into that. So we obviously needed money to build this sort of hardware. It's not cheap, and to get people on board and everything. And so we were very lucky to get some significant government grants pretty early on. My advice around that was, I think the fact that we'd registered some tangible IP in the form of patents was incredibly useful. We had some early customers, so even though we didn't really have a product yet, we had the knowledge to do testing in a different sort of way, and we went out and we got a few consulting projects where we went into other people's labs and we set it up for them. And so having a bit of revenue and a bit of proof that this is something that's useful to people, I think was also a massive help. And we also went around and asked a bunch of people, if this was developed, would you buy it? And we got letters from people saying yes. And I think that sort of proof around the concept was really helpful in getting that together.
So can I just
yeah.
So one of the challenges when you're
Yeah.
is yes, it's great to have your IP protected, and that helps you. Do you think that the stopwatch starts as soon as you put in your provisional, and suddenly you've got a 50k bill, like 12, 18 months, whatever down the pipe?
Yeah, for sure.
What sort of judgments did you make about how many things? Often you might have a patent family you're trying to develop. Do you patent all at once? Do you just patent one or two key things and then hold off, or
we basically kind of went bare bones, get some applications in around the concepts we were trying to protect, and we certainly didn't have enough information around it to have a really strong patent. But we just wanted to register some stuff to show that we've got some protectable ideas that we're working on.
So the tool at the beginning to attract investment as opposed to necessarily trying to protect.
I think that was one thing, plus just setting a priority date so that we got in early on the ideas. And yep, you're absolutely right. The clock starts ticking, and you got a certain period of time to get it all together. And for a few, we were able to get enough information. For some, we just filed them again. So it gives you another 18 months. Of course, the first 18 months, if someone else had lodged something similar in that time, you lose out. But I don't think, there was any harm in putting it in early, and then when the clock runs out, you can just resubmit it and keep working on it.
Assume that by the time that clock was running out, you would have something.
Yeah, that was the idea. Yeah, yeah, and just to be, the core concepts and a bit of evidence around it had been done, but not enough to have a really solid patent, and so we assumed that over the 18 months we would either generate all that information and we'd have a really solid patent that we could put in, or it might just be irrelevant and we'd ditch it. So yeah. So that was our approach there. So just on the bootstrapping theme, so we were able to kind of continue that theme of getting early customers in consulting-based projects that kind of allowed us to generate a little bit of revenue that we used to match the government grants. And University of Newcastle was very supportive of us early on, and also CSIRO and DPI, all very much involved in lab testing and have been very supportive of us, which allowed us to generate a bit of revenue and also get that experience. So as we're building our products, we're building the right thing, and I think that was certainly very important for us early on. And we went as far as getting some more loans just to keep it ticking over, and postponing the raising of capital as much as possible. But eventually, I think it was inevitable that we needed to raise some money from investors, and with that, it brings a lot of new complexities and new problems, but at the same time, I think it brings a lot of focus, because now that people are putting money into your business, they really want you to achieve certain goals. And whilst that's a bit confronting, it's also great for the business, I think, to have us being pushed really hard towards achieving certain goals. We kind of made the decision that we were going to raise some money, and I think number one, having our advisory board together with some key local business people was just so important in making that happen. Basically, one of our first angel investor organised the whole thing. So he connected us with investment firms in Sydney, people in the local area, and I worked with him, and we pulled it all together, and without him it would never have happened. So I think it was very important to have this advisory board to help us out. Of course, there was a whole lot of work that went into it. So to anyone who hasn't been through the process, I'd make that very clear. We had to do a whole lot of things, not only getting a good pitch deck together and an information memorandum, which involved quite a bit of work. All of the legals around it, when you bring new investors on, you sort of have to make sure that the company structure is set up right and all the legals are in place. And there was a whole lot of things to consider: valuation, what sort of money we bring in, convertible notes, a safe was another option. I don't know if you've heard of that. And yeah, I think in the end we decided to put a value on the company that was agreeable to everyone, and just take straight capital and equity. Yeah, so early on we brought on some local angel investors, and we got a farming cooperative on board, which they've turned out to be basically our key or core development partner. They've provided so much information for us, and we're working really closely with them. And we also got a venture capital firm in Sydney on board, and they've really been instrumental in really pushing us towards achieving certain goals. And at the moment, I think it's been a very beneficial thing. We'll see how that plays out over time. Yeah, so I thought I'd also talk about some of the challenges we've had, because might look like a nice story on the surface, but underneath there's certainly, you know, the ugly side. And number one, taking a bit of hardware to production. Now, you know, our hardware is not simple, it's quite complex, and I think when we first started on the journey, we knew it wouldn't be easy, but we had no idea what we were getting ourselves into. I think I got some photos. Yeah, we kind of very early on got to this point where we had a system on a breadboard, and that was functioning quite well, and we were pretty happy with ourselves. We thought, you know, all we got to do is miniaturize that, stick it in a box, and we'll be away. Many stressful months later, we ended up over here with a miniaturized version of it that seemed workable, and a bit of a concept for what it was going to look like. And I think once again we thought, cool, we've got this, be pretty easy, take it to the next step, get someone to make it. Yeah, so fast forward another year, and we've got our engineering verification tests here, and there's been a lot of very amazing engineers that have put work into getting it to this point. You can see it's not a simple product, it's quite complex. This is our optical chassis up here. We had to search around to find someone in Australia who'd be willing to try and make that. From one solid piece of brass, they machined this high tolerance optical chassis. And the guys that did it, they said, before this, the most complex thing they'd ever done used 9 of their CNC tools, and ours used 25. But they got it done, and yeah, and so we ended up with these engineering verification test products that were quite complex, and they've got over 100 parts. You know, every single one of those parts, there was some sort of issue that we had to sort out, or a supplier that we had to liaise with. So not a simple process. The other part of it is we had to come up with our own optical alignment procedures. So we had to build our own custom optical alignment tools. So over here you can see some of these tools here are sort of custom optical alignment tools, and we had to come up with a whole procedure for putting all the lenses in and aligning them to certain tolerances. So that was another huge undertaking. We'd originally wanted to just outsource that to somebody else, but we realised that it needed to be done in-house due to time and other cost restrictions. So yeah, we went through this whole process ourselves, and basically this was a process of figuring out where we can simplify things, where it's very very difficult to put something together, and just looking for any opportunity to simplify, to make the process of building it a lot easier. And now we're at this point where we are trying to palm this off to an external manufacturer who's actually a Singaporean-based company. They've been very, very helpful. They sent a team of Singaporean optical engineers out to scope it all out. And yeah, it's really, once again, a process that we're doing right now, which is simplifying the assembly process and the alignment process, so it's actually viable to get these made externally. And yeah, so that's where we're at now. As you can see, it's been a very long journey to get to here.
So why did you choose brass instead of molding out plastic? I thought the optics were really important in alignment, but the thermal expansion of the brass might actually cause you alignment issues.
So we actually needed a heat sink, and so yeah, because the onboard lasers and photodiodes needed to dissipate that heat into something. Yeah, we're certainly exploring other options down the track. Yeah. Yeah, I mean, of course, there's been a whole range of challenges, but another one I thought I'd mention was, you know, the first time we've had a bunch of MVPs along the way that we've had out in the field being used, and as we developed this smart lab product. And so, yeah, the reliability of our MVPs has been another huge learning curve. We built a product, I think I got a picture. We built this sort of simple product in a box that worked very nicely back in the lab, and we thought, you know, send them out in the field, everything will be okay. Turns out it wasn't. Once we got them out in the field, we started seeing all of these errors coming in, and I think this is just a natural part of the process, but it was a huge learning curve for us. I think, yeah, I've got an image here of it being duct taped together. We had a problem where the glass surface was getting really hot and burning the samples. So this was a little quick fix in the field. But there's just been a whole array of small bugs that just made it not usable for the people out in the field, and over about a month we basically dealt with all of these problems, and we've now got a pretty stable device that works quite well. So yeah, I mean, we've obviously had a number of pivots along the way, but I might leave it at that, and yeah, if anyone's got any questions, shoot them through.
So your market, I know, you're tending to sell directly to farmers, or are you going to be selling to, like, you've got a cooperative on board? Are you, like, how are you sort of, what's your sort of, B2B or B2C, or not sure yet? Or?
Yeah, so we're going to go through channels, and the farming cooperative is number one. So they're very well respected in the local area, and they got kind of access to the agronomers who we're aiming at first. And yeah, we've got kind of a whole strategy around how we're going to roll it out through agronomists and then to the larger agronomy companies. And yeah, definitely using channels. So in the very early stages, we're doing direct sales, just because we really want to be there with the customers and learning what they want, and making sure everything's, you know, going well for them. But once we get past that point, we're going through channels for sure. Yeah.
So you've got sort of two training challenges. One is training your AI, but then the other one would be to train the actual operators themselves.
Yeah.
So what sort of strategy do you use for both of those?
Yeah, so well, I guess training the AI first. So we got pretty standardized systems for doing that, and that comes back to the whole development partner thing. So we find people who have access to a large number of a certain sample type, let's say wheat grain, for example, and we work with them to scan in a large number of these samples to cover kind of the variation that you'd expect to be grown. And our AI, it's all automated now. automated the whole process. You scan the samples in, it comes into the software kind of puts the data set together, optimizes a whole stack of things to create the most optimal algorithm at the end, and then you can sort of publish that to our app. And so that whole system is where we put a lot of our development time into just making that completely automated, and so the computer optimizes everything for you, and having a system at the end to assess the quality of a calibration. So having a whole lot of metrics that we look at, and so we can tick off, yep, this is good enough to list on our platform or not. So yeah, there's that process that's pretty standardized now, and we hope we can kind of roll that out into a whole bunch of different industries and kind of let the development partner lead the way in what they calibrate for and the particular application, and we're just sort of the platform that provides that path to market. Yep, so that's that. And then on the other side, training the users. So we've designed the devices to be foolproof, but they're not. Yeah.
Something like, let's say you're using it for soil testing.
Yep.
And so soil is this horribly, like non-homogeneous thing.
Yep.
And so, and you've only got quite a small sample volume. And
Yep.
so if they don't take a representative sample, then they're going to get an answer that's completely skewed.
Yep.
It's got a big stick in the middle of it, and suddenly that changes everything.
Yeah. Yep.
So is there, you just like agronomists that have existing training about how to sample properly and all that sort of stuff, or do you actually?
Definitely, yeah. So it's also part of the strategy of going to agronomists first. They certainly very cluey about all of that sort of sampling, the sampling side of it. We've also we're getting better and better, and there's a lot more we can do, but trying to build things into the app to kind of educate people. So we already have an averaging process that for different sample types has different suggested methods of scanning, and we've built an automated system that will basically, in your soil example, if there's a big stick and they scan the stick, it'll flag that and cut that. So we're trying to build systems into the app that kind of educate users and reduce the chance of poor scanning technique. Yeah.
So you're working with partners on developing the data set, basically, is that right? So
Yep.
So what happens if you've got an existing data? So let's say you're in wheat, someone said, here's my wheat samples, but then later on I'm a producer who's particularly interested in hard milling wheats, because that's what I really, and so I want more discernment around that, and I want to bring a new set of sample sets. How do you manage because you've got one partner you've already worked with there that's actually on your app, and then this person comes in with an overlapping data set. You've got ways of actually managing that in terms of being able to use both data sets to get better resolution, and to organise how that gets divided between the two.
Yeah, so an issue that comes up all the time. So our view is we're like a marketplace. If two different people want to build the same calibration on the same product, we will let them do that. In the early stages, we're obviously trying to not double up on things, so we're finding people who do different things. But certainly two different people could list a very similar solution, and like you say, one might be focused on hard wheats and one might be soft wheats or some small variation. We allow that to be listed, and people just load in the calibration that they want to use. Yeah. And then I guess there's for us, there's a great potential in going and approaching the 2, 3 or 4 or 5 people who've developed a similar application, saying, do you want to join all this together and build one universal calibration that kind of covers more stuff? And yeah, we haven't got to that point yet, but we would go and approach the different parties and say, look, if you combine forces, you can make something better than what you can individually do. Yeah, but we're trying to stay kind of agnostic there. We let people do what they want. Yeah.
Keeping a free marketplace.
Yeah. Yeah. Yeah.
What kind of limits are you, what possibilities or how far can we go if I wanted to do bitterness in lettuce? Can we talk to you?
Yeah. So it's a bit of a difficult question. We have some pretty good ideas about the sorts of things that we can detect, and there's a whole lot of variables around that. A whole lot of reasons why we might not be able to do it, and a whole lot of reasons why we might be able to do certain things. So as a development partner, we come and do an early kind of viability trial with people. Firstly, just using our experience to tell you if it's likely to be viable, and then we'll do a very small run to get some data about whether it is viable or not before we go and do the full scale calibration process. Yeah.
What are some of the key things that you can test for at the moment?
Yep. So we're basically using our MVPs at the moment in the field to do real testing, and we're starting with grains. So we're doing canola grains, wheat grain, barley grain, and there's some key variables that farmers want to know because they get paid off it, and they're things like protein, oil, moisture, which are fairly simple things in the scheme of it, and so we're starting there. We're also doing some simple soil measurements, soil moisture, soil nitrogen, things like that, and the Smart Lab device that is soon to be released, it allows us to measure liquids a lot more effectively. So we're targeting some wine metrics early on with that, things like alcohol content, acids and sugars in wine. So yeah, that's some of the key things we're focusing on initially.
So in terms of things like you can pick up like lipids and proteins and stuff, can you actually look at, like if you get into the lipids, can you actually work out a lipid profile of different lipids, or is it just total?
Yep, so we've actually done that before. Yep. So we did a project looking at it's actually tobacco leaves that were genetically modified to create different lipid profiles, and lipids work really well. So we were able to distinguish the different types of lipids pretty well. Yeah.
And proteins and sugars, can you do a similar thing?
Yeah. So I probably haven't given quite enough detail about the devices, but we have two different devices and two different types of spectroscopy. The first, which is our MVP that we've got out there right now, is a near-infrared spectrometer, and it can do certain things, but it's quite limited, and it struggles with distinguishing different types of sugar. Our other device is much more high-end and has a lot more capability, and it certainly distinguishes the different types of sugars really well. Yeah.
Do you have a plan to keep those as two separate products, or are you going to work out how to?
Yep. So one's a kind of low cost, a lot smaller solution. The type of thing that would potentially in the future could even be built into a phone, because it's a very small chip. And the higher end product is what you've seen with an optical chassis, and we've made it quite small, but different price points, different size, different capabilities. Yeah.
Any more questions? Thanks so much, Antony. It's been fascinating.
No worries.
Oh, so you're on.
Yeah.
This has been like a really big, long, fascinating journey. But how has been your experience going from a researcher to an entrepreneur, and what would be your best sort of advice or biggest challenge in the change between those two roles?
Yeah. So yep, it's been a huge journey. Like, we had no idea what we were getting ourselves into at the start. And I think over time, you know, we started very much deep in the science and you know, getting these things working, and that was 100% of my day. I'd come in and work on the science. And over time, that just reduced to 90%, 80%, 70%, and at one point it probably was 0%. I was working on fundraising, working on just finding people, the business side of it. But it comes and goes. It's a bit of a roller coaster. We sort of hit a spot where we realised, all right, we all need to pull in and like get this part working, and we come back and, you know, get on the tools and do the science, and then back into the business. So that's kind of something that I just slowly crept up on me, and then I realised I'm not actually doing any science anymore. And I think there was a huge learning process there, and without our advisory board and some of their investors, especially the VC firm that's come on, we would never have been able to do it. They've really, I'd say they've given us a crash course in business over the period of time. So yeah, definitely if you're a scientist and you're trying to learn the business side of it, I very much suggest getting an advisory board or or investors that are very involved and willing to kind of walk you through the process. Absolutely. Yeah.
Is that something you were considering when you were looking to fundraise? Initially, I guess most people are thinking about how much cash can I just get so I can keep moving on to develop the product. How much thought had you given at that early stage about what sort of support and advice that those investors could actually give you, and has that turned out to be as or more valuable than the actual cash?
Yeah, so that was a huge consideration. I think that's one of the big reasons we tried to get the farming cooperative on board, because we knew they had the connection to the customers we were trying to access, and they had a lot more knowledge about agriculture than we did. And so that was a huge part of getting them on board, and they've turned out to be worth a whole lot more than the money they put in. And yeah, with the angel investors and the VCs, I think we probably put less thought at the time into what they were going to bring to the table, and we were kind of pleasantly surprised that they spent so much time with us. The second they signed on, they were up here in Newcastle every week, kind of working on the business with us. And that was a huge surprise. We thought they'd just kind of put their money in and wait, like we'd never see them again. And so now, because we've done one seed round and we're now raising more, and so this time we're definitely considering, you know, what else do they bring to the table? Yeah, absolutely. And I'd say it's worth more than the money, for sure. The VCs that we have in Sydney, they've, you know, brought projects to the table, so they've brought revenue to us, and they've helped us map out our business plan, our whole strategy.
And sorry to cover this earlier because I think we're a bit late, but after ag, what's the next horizon? What are you thinking about as an application?
So we're certainly already working on medical applications, but we know it's a long path and we got to make sure we get it right. So we're kind of doing that in the background, and we hope it pops its head up soon. Yeah.
When do you think I can just go buy one of these things? What's the timeline?
Yeah, so I guess first of all, with manufacturing, there's quite long lead times that we've also learnt. So we have a certain number of devices on hand now, and we're being very careful about who we give them to. And we're looking to scale up the manufacturing early next year. So yeah, early next year.
So do you assume you'll make most of your money out of the website and stuff, or out of the actual selling device?
Software.
Do you end up selling the device at cost or
it's software. So we're trying to give devices away so that people do more scanning and pay more for the software. Yeah, but we've had to do all this modelling to figure out how much do the devices cost, how much are people going to scan and pay for the use of the software, and kind of similar to a phone plan, we kind of have to put them on a certain period of time, 2-year contract, and over the period of the contract it pays down the cost of the device. Yeah. And our whole mission would then be to encourage more testing. So the higher volume testing, the more revenue we bring in. Yeah. No worries. Thank you.